Hi, I am Chiamaka Chukwuneke, and I'll be giving a talk on our work, which the topic is Igbo NER 2.0, Expanding Named Entity Recognition Datasets via Projection. This work was done in collaboration with Doris Aswagwa Chidema Chinedu Mbon and my PhD advisors Paul Rayson, Ignatius Ezani, and Mahmoud El Haj. There is always a constant need for annotated corpora in NLP tasks. An African language, Igbo, has few annotated data sets for NER tasks. We adopt the cross-language projection method to automatically create more NER data sets. We build a mapping dictionary containing all the unique entities identified by Spacey Tagger with their tags. The table here describes the parallel data and their sources. The Igbo and English sentences was collected from BBC News and local newspapers. Here is the description of our data set. We use the Spacey tagger to tag the English sentences, and for this work, we will be using only these four entities: person, location, organization, and date. We have the number of tagged entities, we have the Cohen-Skappa inter-annotation agreement score, and we have the disagreement percentage between the annotators. Figure 1 here illustrates the semi-automatic process used in creating the mapping dictionary. The English source sentences and the Igbo sentences are passed into the pipeline, and we have an initial mapping dictionary that was empty. The English sentences are passed through the Spacey tagger, which produces an output of each sentence containing the entity and their tags. Then the outputs are passed to check the following: if the entity is already in the mapping dictionary, and if it is already in the mapping dictionary, it discards the entity and picks the next entity to check. But if the entity is not in the mapping dictionary, the entity is now checked in the corresponding Igbo translated sentence, and if it is in the sentence, the entity with its value is added into the mapping dictionary. And in the mapping dictionary, we have the key as the English entity, while the value is the translated Igbo entity and the tag. Then if the entity was not identified in this sentence, the entity is now manually annotated and is added also into the mapping dictionary. The mapping dictionary is updated at the end of the process, and this mapping dictionary was used to transfer the tags identified by the Spacey tagger to the corresponding Igbo sentences to produce our data set. We did some experiments using our data set and also the data sets from Masakane community. We combined the data set we created in this work with the previous data sets we have in Igbo, which was produced by the Masakane community, and we split these data sets into 4 parts: 25% of the data set, 33%, 50%, and 100%, which was used to experiment on these models. And from the experiments, we can see that these models, when fine-tuned, the results, there was increase in performance as the data set increases. We can also see from the table that the XLMR outperformed the other models with F1 score of 88.83, while our Igbo BETS model with F1 score of 79.91. We can say from that the Igbo BET is comparative to these other state-of-art models when we compared the amount of data used in training the Igbo BERT and these state-of-the-art models. In conclusion, we propose an approach that takes advantage of parallel data in English and Igbo. A mapping dictionary was introduced, which enables the automatic transfer of the NER tags produced with the English NER tagger to the corresponding Igbo entities. Our experiments show that model performance improves with increase in the data size and when fine-tuned in NER downstream task. We acknowledge the support of Tertiary Education Trust Fund, TED Fund Nigeria, for funding this research. We also thank the anonymous reviewers for their useful comments and for reading the draft. Thank you.